Hello and welcome back to our multi-part series in statistics. My name is Manny. Let's begin. This is presentation 7.7 and the topic is inferences regarding proportions and sample sizes, and the development team is below here. Now for illustration, we want to talk about a poll, n equal 588 people, 321 of whom indicated he or she would vote conservative if the election were held today. Now this was in the last election. We need to find a confidence interval for the population proportion. And then we have a point estimate of the population parameter is p hat. This is x over n of 54.6%. This is an estimate of p. And the standard deviation in the sample proportions is given by this expression. Note we're using p hat in this expression since we don't know the value of the parameter itself. And calculating this value is 2.05%. And this represents a symmetric region about the true proportion, which we don't know, with 60% confidence. The 95% margin of error then is your z-score, 1.96 times your standard error, giving us a margin of error of 0.04, and that's represented here on the screen in the yellow. Now the confidence interval becomes as follows. We're saying that p hat is 95% chance of somewhere in this interval, so we'll place it in there. No, we don't know where this above figure is situated, but however we have p hat 0.546. We add and subtract the margin of error, giving us this confidence interval 50.6% to 58.6%. And 95% chance that interval will capture the true proportion. Now we're going to look at sample sizes. We're looking now at the notion of how large a sample size is necessary to find an estimate of p to within plus or minus 0.02 with 99% confidence. This plus or minus 0.02 is the error, and in this figure above we want to reduce this 0.04 to 0.02. So going to our diagram here, we're saying for 99% confidence we want this interval to be plus or minus 0.02. Your z-score, z-score 2.575. And note here, we know everything in this formula except n. Now we're looking at this part here, solving for n. We square both sides and we find the following. And n becomes 4110. So we must go to a sample size of 4110 to achieve this degree of reliability. Solving for n, generally we have this formulation here. And now we're going to look at the case of what happens if we don't have an estimate of p. In other words, we haven't taken a sampling. And we're going to start with this general formula here. And we're going to look at a 99% case and an error term of plus or minus 0.02. And you see it coming on the screen here. See, we know these values on the left, and over here we have, note that this is the quadratic in p hat, and the intercepts are p equals 0 and 1. And we're going to look at a graph. It's inverted parabola, it's a quadratic, and the intercepts here for this graph, where across the bottom we have our estimates of p hat, and above the vertical axis we have the sample size n. And you see it coming on the screen here, and as a vertical axis. And over here we're looking at several examples of p hat. And for example, if p equals to 0.20, this is your sample size, 30%, 40%, and 50%. Now beyond 50% it starts going down the other side. So the maximum is reached at p equal to 1/2. And simply the case that if we put p equal to 1/2 into this formula, we have this expression, and this right side of this expression reduces to 1/4, and this becomes your sample size n necessary if no value of p hat is available. And the general equation is as follows. When p hat is 1/2, and this becomes the general equation 1/4 times z squared over e squared. And that's the end of presentation 7.8. We ask you to take notes as required and proceed to 7.9.